Hello, I'm going to go through the answers to the photoelectric effect questions that you did in your 10th period. So, number 1. Light of frequency 2 times 10 to the 15 is incident on a metal surface. The work function of the metal is 4 times 10 to the minus 19 joules. Which statement is correct? No photoelectrons are released. So we need to work out whether the energy we've got here is bigger or smaller than this. So our energy of our photon is HF, so we do H times the frequency here, and we get 1.3 times 10 to the minus 18 joules. Then if we want to know how much energy, kinetic energy, the electrons are released on, we do phi minus that HF. So we're going to do the work function there, 4.6 times 10 to the minus 19, minus that energy we just figured out, and you should get, I think it's 8.66 times 10 to the minus 19 joules, which is C. Okay? 2. Photons of energy 1 times 10 to minus 18 joules are incident on a metal surface and cause the emission of electrons. Which statement about the emitted electrons is correct? They have a kinetic energy of 1 times 10 to the minus 18. Well, no, HF is phi minus, plus KE. So they've got to have this phi, so it's not that one. They have a kinetic energy that's a multiple of that. No. Their mean kinetic energy is that. No. Their kinetic energy must be less than that. Yes, because they've got to get the phi. So it's D. Okay. Next, the graph shows how the kinetic energy EK of photoelectrons emitted from a surface varies with the reciprocal of the wavelength. What is the gradient of the graph? So we're going to compare this to the equation of a line. So HF equals phi plus EK. We've got EK on our y-axis, so we need to make it look like y equals mx plus c. So I'm going to rearrange this for EK. And we get phi minus HF. Okay? Sorry, wrong way around. HF minus phi. Okay, we haven't got frequency, we've got wavelength. So I'm going to write that equation as hc over lambda. And then to make it look like y equals mx plus c, I'm just going to put the 1 over lambda to the side, which you can do, because that is the same as that. So if I compare it to y equals mx plus c, that's my c, that's my x, and then that is my gradient, hc. So it's C. Okay. Question 4. Photons of wavelength 290 nanometers are incident on a metal plate. The work function of the metal is 4.1 electron volts. What's the maximum kinetic energy of the electrons emitted? So I'm going to work out E equals hc over lambda to get my energy. So I'm going to do 6.63 times 3 times 10 to the 8 divided by my wavelength, which is 290 times 10 to the minus 9. So that gives me an energy of 6.85862069 times 10 to the minus 19. I'm going to divide that by E to get it in electron volts, so 1.6 times 10 to the minus 19, which gives me 4.2866 electron volts. And then I want to work out kinetic energy. So kinetic energy is, we just did it here, yeah? HF minus phi. So this is my HF, 4.2866, and my phi is 4.1. So my answer is 0.1866. which is 0.19 electron volts, which is A. Okay. Question 5. Which statement suggests that electrons have wave properties? I mean, we've not studied waves yet, so you will get better at this, but it's C. Electrons produce dark rings in diffraction experiments. Sorry, I didn't realise 5 was on there, and you don't really know that, so don't worry about 5. Okay, 6. When illuminated with electromagnetic waves, a metal surface can exhibit the photoelectric effect. The maximum wavelength that causes the emission of photoelectrons with zero kinetic energy is 6.8 times 10 to the minus 7 meters. No, frequency, hertz. So that's for when we're only just emitting electrons. So that's when our HF equals phi, that's our frequency. Okay, because we've got no kinetic energy. And the question says show the threshold frequency is that. Oh yeah, sorry, we've got a wavelength. Oh, we need to prove that. Our wavelength, sorry, is 6.8 times 10 to the minus 7 meters. So we're going to do E equals HC over lambda. No, we're not, because we're going to do, F equals C over lambda. So 3 times 10 to the 8 over our wavelength. So this is a GCSE equation, yeah? That gives you your frequency. Next, we're going to work out the work function. Well, work function is equal to HF when our frequency is this, because we get zero kinetic energy. So you just do 6.63 times 10 to the minus 34 times 4.4 times 10 to the 14. Which gives you 2.917 times 10 to the minus 19. And you're allowed actually up to 2.93 times 10 to the minus 19 on the mark scheme. Next, calculate the maximum kinetic energy when you actually shine a photon of frequency 7.8 times 10 to the 14. Maximum kinetic energy. So, HF equals phi plus EK, because we've got kinetic energy this time. Rearrange for kinetic energy. So our photon energy is here, so we're going to do 6.63 times 10 to the minus 34 times our frequency. We're going to take away phi, and our phi we're given in this question. You can of course use your answer from here. Basically you get an answer of 2.2 to 2.3 times 10 to the minus 19 joules. So any value in that range is fine. Okay, B, explain why the photoelectric effect cannot be explained by wave theory. Again, we haven't really done wave theory yet, but basically, in the photoelectric effect, no photoelectrons are emitted below the threshold frequency. Which means, but with wave theory, electrons would always be emitted. So whenever the light was shining on it, electrons would be emitted. But when we do the wave topic, you'll understand that a bit more. Okay, next. 7a. The apparatus shown in the figure talks about photoelectric effect. The intensity of the light source is reduced. State and explain the effect on the emitted photoelectrons. So intensity is proportional to the number of photoelectrons released, because it's the number of photons you get. Okay? There is one photon per photoelectron. If you reduce intensity, the number of released electrons is reduced. Okay, 3 marks. You can also say that HF is unchanged, so they have the same energy, for a mark. And you can also say there is no change in their kinetic energy, for a mark. So 5 things you can say there to get a mark. The main points are these 3 though. Explain why no photon electrons are emitted when a blue filter is replaced by a red filter. So photon energy is proportional to frequency. Okay? The frequency of red light is smaller than the frequency of blue light. Okay. So therefore, the energy of the red photons is smaller than the energy of the blue photons. And it is the energy is not enough to overcome the work function. And that last bit's important because it explains why there's none emitted, linking it to the work function. Last bit. When a metal of work function 2.3 times 10 to the minus 19 is illuminated with ultraviolet radiation of wavelength 200 nanometers, so 200 times 10 to the minus 9, calculate the frequency of the ultraviolet radiation. So frequency is the speed of light divided by lambda. So 3 times 10 to the 8 over 200 times 10 to the minus 9, which is equal to 1.5 times 10 to the 15 hertz. The threshold frequency of the metal is when phi equals HF. Okay, you want frequency, so it's phi over H. I can't rearrange equations today. So you're going to use your work function, which is 2.3 times 10 to the minus 19 over H, which gives you a value of 3.5 times 10 to the 14 hertz. So that's our threshold frequency. Then it says calculate the maximum kinetic energy of the photoelectrons in joules. So HF equals phi plus EK. I mean, we've done this 3 times already, yeah? EK equals HF minus phi. The energy of the frequency of our photons is this. So H times 1.5 times 10 to the 15 minus our work function, which is here. 2.3 times 10 to the minus 19. That gives me a kinetic energy of 7.6 times 10 to the minus 19 joules. Okay. If you still don't understand some of that, you need to come and talk to me. Thank you.